Okay, so this is a review of when we talked about translations and reflections of linear functions. So we talked about this word translation and we talked about the word reflection. When we talk about translation, I kind of like to look at this SL in here. When we translate, we do something called a slide, and that is vertically, so up and down, or a shift. You can call it a shift also. Then we talked about reflections, and we talked about when you look in a mirror, you see your reflection. And I also look at this FL here. When you do a reflection, we call that a flip. So translations, we slide up and down, and with a reflection, we're going to flip our line. So we talked about when we translate a linear function vertically, which means up and down, vertically up and down, what's going to happen to our slope? So if we shift this line up or down, what's going to happen to it? So if I plot the points 0, 3, so this is 0, 3, and I plot the points -3, 1, and I sketch a line. I'm just going to kind of sketch it here. Sketch, 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 sketch. Not perfect, but it's good enough. What happened to my line when I shifted this line? Looks like I shifted it up. When we shift our lines, when we look at the slopes are going to, I'm going to put slopes. The slopes are going to be the same. Nothing happened to the slope of our line. This slope is going to be the same as this slope. Now, let's look at this y-intercept, because you know the y-intercept is the point that crosses this y-axis. What happened to our y-intercept? It looked like it shifted up, right? So it's different. So the y-intercepts are going to be different. All right, so when we do a translation of a linear function vertically, up and down, the slopes stay the same, so the slopes are the same. The slope is the same as this slope. But the y-intercepts are going to change because, of course, you're shifting it up or down. So this point is different from this point. Lines that have the same slope, we talked about them being parallel. Remember the two lines that look like a parallel? So if they have the same slope, these lines are called parallel lines. All right, so that's our translation. Translation, sliding, shifting vertically. Now we got to talk about reflecting a line with a linear function. If I reflect the line or flip it, let's say I have to flip this line. And again, I'm going to sketch a line here, right through there. I just kind of flip my line. What happens to my slope? Actually, let's start with the y-intercept because that's pretty obvious. The y-intercept of these two lines is the same. So the y-intercept doesn't change. The y-intercept is the same. Now, do they have the same slope? No, because we know that the same slope, they'd be parallel. These lines are not parallel. They're perpendicular. So the slope is going to be opposite. And what does that mean? If I have a line that has a slope of 2 and I want the opposite, the slope is going to be -2. All right, so again, reflecting, we're flipping the line. Slopes are going to be opposite. The intercept is going to be the same because they're going to cross each other right here. Translating, sliding, shifting up and down, the slope stays the same, but the y-intercept shifts. They're different. So we worked on it with these equations, and we were looking to see what transformation occurred from f of x to g of x. So here's f of x and here's g of x. So we have f of x equals 3x plus 2, and we have g of x is 3x plus 6. hopefully by now you recognize this is the slope. This is the slope. 3 is the same as 3. They have the same slope. Same slope. This is, remember the y, I should probably write this y equals mx plus b because, you know, we have to keep remembering it. Slope, y-intercept. M is slope. Y is your y-intercept. All right, so we have the same slope, but we went from a +2 to a +6. So what happened to our transformation? Well, it looks like we're talking about the same slope, so they must be moving vertically. So we went from 2 to 4. So to go from 2 to 4, I added 4. So we did a shift, and we went up 4. So we went up 4. We took this line, and we just moved it up 4 from a 2 to a 6. So it would always be like if it were here, it went from a 2, shifted up to a 6. Parallel lines, same slope. Let's look at the next one. We have f of x equals, and remember there's always kind of a -1 here, -1x plus 2, g of x equals -x minus 3. So if there's a 1 here, we're just going to say there's a 1 here. -1 and -1 is the same slope. Same slope, okay, that must be something up here that we're doing. We must be doing a shift. We went from 2 to -3. So how do we go from 2 to -3? You can look at it by using this, take the second number and subtract the first number. So -3 minus a 2, always use your calculator because sometimes you always think you know, but you don't know. -3 minus 2 is a -5. So we shifted down, because we're going -5. We shifted down 5. So we took the line where it crossed it at 2 and shifted down to the y-intercept of -3. So we shifted down. Again, look at, we have f of x equals 4x minus 4 and g of x equals 4x plus 3. Same slope. I have a 4 and a 4. Same slope, but look at our y-intercept. -4 to +3. So I'm trying to start to think, okay, I'm going from a -4, so it'll be down here, and I'm shifting up to a 3. So I must be going, I know I'm kind of shifting going up, but how much did I go up? Remember, take 3, the second number, and subtract the first number. This is where it gets iffy, because you got to do a minus -7. If I do it in my calculator, I'm sorry, I messed up 4. 3 minus a -4. I was getting ahead of myself. 3 minus a -4 should give you a +7. So you're shifting up 7. So you started at the y-intercept of -4 down here somewhere and moved it to 3. It's going to shift up. The next one, here's where we might see something a little different. Look at our slopes. Our slope is -2 and +2. That is opposite, just like we did up here. So that means they're not parallel anymore. They're probably looking something like this, perpendicular. Let's look at our -4. Actually, I think that's all we have to do. I think right here, because the -4 and -4 is the same, we're just going to call this a reflection. So if I could spell reflection, that would be great. All right. So we reflected or flipped this line. We reflected or flipped this line. So the line would intercept, it looks like at -4, you'd have probably one line going this way and one line going this way. Think about a negative slope would go this way, a positive slope, the line would go up this way. So it's a reflection, a flip. And the last one we did, we looked at these, oh again, here's a -1x and a +1x. They're opposite slopes. Opposite slopes. We have but we have different intercepts. So we have a 3 and a -3. All right, so we definitely did a reflection because we have opposite slopes. definitely a reflection. But what happened to this reflection? We went from a positive 3 to a negative 3. Positive 3 to a negative 3. We went from all the way up a positive 3 all the way down to a negative 3. So what did we move? Well, remember, let's start at negative 3 and then subtract 3. Now that might think, oh, it's 0. It's not. So put it in your calculator. It should be 6. It should be a negative 6. So if it's a negative 6, you reflected down 6. You reflected the line down. You went from a positive 3 interception down to a negative 3. So it was a reflection, and you went down 6.